This is cool. So I didn't prepare a presentation, just a quick demo. I'm currently learning AI and deep learning, and I just want to make a quick demo of how easy it actually is to use right now, and a little bit of context. So for anyone who doesn't know what deep learning is basically when you have a neural network, and you have, very simply put, right, you have inputs to this neural network and it gives you the outputs. The inputs can be everything is numbers here, right? So the inputs can be an image represented as RGB intensity, for example, because each pixel is essentially your RGB with three components. So you can actually represent your image as a linear array of the RGB components. And so you feed the image to the neural network, and let's say you want to classify whether an image is a dog or a cat. And that's what you want your neural network to output. A neural network will itself figure it out, how to classify dogs versus cats. And like 5 years ago, you needed a team of researchers to do that. I will do this right now in a few minutes. But I will be classifying Xbox versus PlayStation. So let's start. I wanted to code it live, but I know I would screw up something, so I just prepared a little notebook here, and I'll just explain. It's really short. So the first cell here is nothing important. It's just preparing and updating the libraries. I use the FastAI library, which is also the name of the course that I'm taking, FastAI. And then DuckDuckGo search. If you haven't heard, DuckDuckGo is like Google, basically. So, okay, let's do this. First, we import the DuckDuckGo search function, and let's start search for some Xbox images, and let's say like max results 1. I should have started the session though before doing this presentation. Okay, just a moment. Just a moment. Oh, crap, okay, yeah, well, apparently it didn't save my state. 30 seconds, please. I cleared all the results, but I hope that it would at least keep the installed packages, but apparently it didn't. So yeah, okay, that's done. Okay, so we got a result from DuckDuckGo. We have an array of objects, and we have a title here, something, and then an image, which is the URL of the image. Cool. Let's put it into a function. Instead of calling DuckDuckGo images every time, let's just wrap it into a function, and let's wrap our results in a fancier list, which we import from the FastAI library called L. Naming, yeah. So nothing complicated, right? We get the results, and then we wrap them in a fancier list. This fancier list just has a bunch of cool operators, so you can transform your data easily. So let's see. Let's search for some Xbox photos. Cool, we got one over here. So let's open it. Here, this is a little bit of Jupyter Notebook, or like the environment that I'm working in, some magic here. But basically, the FastAI library provides you a bunch of convenience functions to download stuff or like work with files. So here we import the download URL function, specify where we want to put the file, and download the first image that we got over here. Download it to the destination, and we don't want to show progress. And after that, we want to show it like literally here in this notebook. So we import a special class called image. We open the file, and then we just generate a thumbnail, a small thumbnail, because we don't know how large the image is. So quick run of that will give us this image of an Xbox. Cool. Let's do the same with a PlayStation image. Just 2 lines of code here, right? We search for a PS image. We need one, and we grab the first result from the array. We download it into, let's say, PS JPEG, and here we also do this. Same image, open, generate thumbnail. Nothing too complicated. And this is not machine learning part yet. This is just like preparing the data. Okay, cool. So now we need to train our model. But for that, we need some data. So we import, again, a bunch of convenience functions here to download a bunch of images and to resize the images, because our neural network only takes an image of a certain size. So you cannot feed just any random image of any random size. You need to kind of resize them, either upscale or downscale. So we will put them into this folder called Xbox or PS, and we will do two searches, right? For one search will be for Xbox photos, the other will be for PlayStation photos. Oh, that's it? Oh, crap, that was...
Quick 5 minutes.
Keep going.
Keep going, please.
It's everything... Okay, let's just run all. Anyhow, give it like 10 seconds. Well, okay, not 10, 30 seconds to just run everything. But yeah, while it's running, I'm just gonna quickly go through the code. Yeah, we're just basically downloading a bunch of images over here, putting them in separate folders, and path is not defined. This is great. From this import path. Amazing. So after that, we just go and verify that images are actually downloaded, because some links are broken. And then the machine learning part starts. So we construct a data block, which is just a block of data that you're gonna use to train your model. And great,
Maybe
path is
import
not
from pathlib.
pathlib. I don't remember. Who's Python expert here? Pathlib like this?
Pathlib has a path object.
Like this?
Yeah, from pathlib. Yeah, that should work.
Okay, so we verify the images, we construct a data block, we specify that our input is gonna be images and our output is gonna be categories. So it's gonna be like either Xbox or PlayStation. Get items is how to get the actual data items to feed into the neural network. Again, the convenience function get image files. Which is going to get it from this path that we path over here. Splitter is a deep learning specific tool. When you train a neural network, you have to split between training data and validation data. So data that you train the model on, the data that you verify that the model is performing well. Get Y is basically get a category here. We just specify the parent label function gets the parent folder of an image. So if your image in /Xbox/ whatever image.jpg, it will get the Xbox folder name. And then item transformers, again, I mentioned get image file. Why is this so freaking broken? I ran it like 2 hours ago and it was, oh, screw this. Anyhow, we resize the images and construct data loaders from this. It should have shown a batch of items here, but it doesn't. And that's it. This is the actual machine learning happening over here with just one call of a function. You specify what data do you want to train on. You specify an existing model. This is ResNet 18 is a pre-trained classifier. So what we are doing here, we are just the library is actually doing it for you. It cuts the head of this model that is used to classify a bunch of images, and it puts a new head there and trains that new head to classify only Xbox or PlayStation images. It does it all for you. And the fine-tune method. This is the method that actually trains the model. And so you specify how many iterations do you want to get. I specify, let's say, 10 here. And that's it. This takes like a minute to train. And voila, you now have a classifier. So this was supposed to download a new image of an Xbox controller. So not just an Xbox, but a controller. To a sample PNG file, sample JPEG file. And this is how you execute it. So learner.predict. Pass it the file name, and it will give you the category of the image that you got and the probability. Unfortunately, everything is just screwed up here. Gosh. Let me try this one last time. That's how demos are not supposed to happen. Okay, cool. We are, okay, cool. Searching for Xbox photos. Okay, I think, okay, now we are, where are we right now? Okay, cool, it's working. So we are downloading a bunch of Xbox and PlayStation photos, and you can see, no, that's fine. This is transparency stuff. Never mind. This is the expected. The folder structure is like this. So we save all the images in Xbox or PS folder under either Xbox or PlayStation folders. So that's where the why this parent label comes in. So it just gives you the name of the folder of a certain image file, right? It's either Xbox or PlayStation. Get image files undefined. Amazing. Luckily, we don't have to rerun everything, so let's just try this. Yep, cool. We have 0 failed files. We construct a data block. So we have a selection of images here. So we are using the squish transformer to just kind of like try to squish it to 192 to 192 pixels. We have some PlayStation Xboxes here, and we are training. Some deprecation warnings. Yeah, so it's gonna take around maybe 30 to 60 seconds here. 10 iterations. So since the model is already trained, it doesn't have to learn all of the new features, as in circles or squares or whatever high level of other features that a model might learn to classify an image. It already knows this stuff. We're just fine tuning it to classify either Xboxes or PlayStations. And we are right now at iteration 2. Gosh, it took faster at home. And all of this is happening, by the way, not on my local machine. Kaggle is a free resource where you can create these so-called Python notebooks, and you can practice with machine learning yourself. It's completely free. You just need to attach your phone number to prevent misuse by like hackers or such, and then yeah, you can use it completely for free. It has a environment Python like machine learning environment pre-installed there. And here we are actually seeing the error rate. So the error rate is, if you multiply it by 100, you will see how many images it got wrong. So in this case, in our first epoch, in our first iteration, it got 30% images wrong on our validation set. So so the second epoch is only 18%, then 9%, 4%, and we are like close to 0. So that means it classifies 100% of images correctly. So we are 70% trained. So every epoch, it just goes through all of the images, right, and it fine-tunes the model. And we have, I don't know how much images we're downloading here. 30 for each, I think. There's download images. Search images. Actually, I'm not even sure how many images are we downloading here. I don't see any numbers here, so might be downloading quite a few images here. That's why it's slow. So yeah, voila. I could have actually stopped at iteration 4, but I don't have a stop button here. Anyhow, the transformer is learned. So now let's download just a sample image of an Xbox controller, and let's classify. Let's see. This is an Xbox with a probability of 99%. And just as a demo, let's see just a PS controller. Let's download that. We have a PS controller. This is an Xbox with a probability of 98%. That didn't work so well. Okay.
So excited.
Confidence is everything.
To be fair, that's an aftermarket PS controller. It does look a bit like an Xbox controller.
Come on, I need just like max images 5. Come on, give me like. Okay, cool. This is a PS controller. This is a PlayStation with but only probability of 50%. So, but if we remove a controller there, and if we download an actual PlayStation, great. This is so broken. This is not the right PS. Anyhow, we have. Okay, so we have a very old PS.
This is why.
And we have a PlayStation with a probability of 99%. So, yeah, I mean, there were some hops and it took me more than 5 minutes. But yeah, doing deep learning right now is really, really easy if you use an existing model, and this Fastai library makes it very simple. There are tutorials, there is a course. So yeah, I'm done. Like, took me twice long, so, but sorry, yeah. Any questions?
More of a question about Kaggle. You can share these notebooks between other developers?
Yeah, yeah.
Oh, that's awesome.
This is public.
Could you share this?
Yeah, of course, of
I
course.
was actually secretly hoping that too.
Yeah. I'll have you look later.
Does Kaggle give you access to GPUs?
Yeah, I don't know what exactly do they give you access to, but there's something running under the hood. The environment is already like created for you, so just kind of use it.
I see.
You can also join competitions.
Yeah.
That's cool.
So I'm gonna share it later, right now.
Thank you.
Any other questions?
Does Fastai allow you to actually work on the model and like switch layers or something, or can you just take in like the whole model? Be like, I want to use ResNet 18 or ResNet whatever, or
It allows you to do both. So it's built on top of PyTorch. So you can
Okay.
either use an existing pre-trained model or you can build your own model, and then use the convenience functions on it.
I see. Okay.
So the pre-trained models are part of Fastai library.
No, they're just on the internet. So there is a resource called Hugging Face, and you can download a bunch of pre-trained models there, including stable diffusions. So stable diffusions 1 and 2 are public, and you can find them here. And so using that stable diffusion API, you can actually run your own stable diffusion, or you can fine tune it to, let's say, generate anime images or whatever. And there are like a bunch of them here. Like there is a waifu diffusion or something, which was this one. Yeah, those are. This is a waifu diffusion. Anyhow, yeah, you can. There is like a gazillion pre-trained models here.
Cool.
Thank you. I didn't know about that.
Okay, if there are no
Last
other
question.
questions. Yeah.
So when you're running the epochs for retraining, do you change the set for training data?
It's automatic.
Okay.
Yeah, every time it chooses, so it randomizes the test data.
So you don't run into overtraining.
Yes, exactly. You can still do it. It really depends on the data that you provide. So I did 2 searches, right? So one search for Xbox, one search for PlayStation. So I have approximately 50-50 distribution. But you can easily overfit or underfit your model by providing the incorrect data. Like data cleaning and data gathering is a big part of it.
It's a whole new field, I guess.
Hmm?
It's a whole new field of deep learning, machine learning in general.
Sort of, yeah.
All right. Any more questions?
The model you're using is just image classifier, is it? Or what sort of model are you using?
Yeah, that's an image classifier. It was pre-trained on like a lot of categories, so by default it can already recognize like birds from cats or whatever. I'm not sure how well it would classify like an Xbox from a PlayStation. Like it could classify like a gaming console probably, but specific details probably won't. That's why we fine tune it on like our specific stuff. So you can use that template as so if you have an idea for your business or something, you can easily train your own model for your specific use case.
Okay. All right. Thank you very much.